CAT for one particular purpose. I can use CAT to copy and paste code from HTML or from a web page into the console or PuTTY, really easily. So CAT is really useful for that purpose. And then we have less, which is a pager, or you can see it as a viewer. Okay, when you say less and then a file name, which is a text file, it is just a viewer for that particular text file. Are there any questions about these commands that is mentioned here? No questions? How many people use VI? Okay. Yeah, VIM, same thing, Okay. Emacs. I don't have Emacs in the VI is fine. Okay. So for the rest of the class, I assume you guys will be using Nano. Okay. Well, VI has a lot of cool stuff. If you use VI improved, it has syntax highlighting, which I find to be quite useful. Sorry?
If you know it, like if you've been using it for a long time, that's good. If you know all the commands and everything.
I think with VI, it's either all or none. In other words, you have to make a commitment and say, I'm not going to switch back to Nano or Notepad. You force yourself to just use VI for everything. Then you can learn it, relatively quickly. Okay, so 1.5. 1.5 is basically just an illustration of how to use all these tools to assemble and run and debug your very first program. Obviously, I have not talked about any of these things, so don't worry if this does not make any sense to you. We are just looking at the tools and also the process to write programs in assembly language at this point. Yes? Make it bigger? Oh, front lights. Okay, I thought font. What did you say? Is that better? Okay. I think next time I can just twist those two tubes over here, so that will just darken the area right in front of the projection screen. That makes it makes it kind of hard for people to take notes. But you guys can buy those LED lamps, the reading lights. And they're cheap too these days. They run on like 2 AAA batteries and they work fairly well. Okay, so what we want to do is to type or copy and paste the following program into a file that has a .s extension. And I will just go ahead and use test.s as the name of the file. And so let's go ahead and do it. Okay, let me do it here. I would do a select inside the browser and then copy. Go to my console and I would just go ahead and create a folder so I can contain all the example code in that folder. And I will make a folder with today's date. Go. And this is how I use CAT to copy and paste from the browser into a file inside the virtual machine. I'm not using a virtual machine, but if you do use a virtual machine, you can do exactly the same thing in PuTTY. Okay, that seems kind of odd. Okay, we'll just take a look at this command here, and I'll explain what it does. CAT is a concatenation program. It will concatenate all the input files into a single output file. Okay? So if you just look at the command itself, cat, it doesn't do anything. Okay, let me just demonstrate what cat all by itself would do. What do you think will happen when I press enter with this command? Just the way it is. It will just pop up a blank line here. Because if you don't supply anything, CAT will assume the input to be standard input, and it will assume the output to be standard output. Now, you guys have all taken C and C++, so you should know what is standard in and standard out. Is that correct? Or if you guys, in your terms, it will be C in and C out. Okay? C in, when you run it like this inside a console, C in is nothing more than, quote unquote, the keyboard. and cout is just the screen. In other words, this program doesn't do anything except to echo what I have typed, because the input and the output are just C in and C out. Now, if I go to change the program to do something like this, cat greater than test.s. Now, this time it will do something that is really useful to me. The program cat is still not having an input file specified. In other words, it's still taking standard in as the input. Whatever I type is the input to the program cat. The output is still standard out. However, the greater than symbol on the command line means redirect output. In other words, instead of using standard out to print something on the screen itself, the output is redirected to the file called test.s.
Can you do the same thing with the input?
Sorry?
Can you do the same thing with the input?
Yes, you can use a less than to specify redirection from some other file as your input. But I don't want to redirect the input in this case, because I want to just do this, press the enter key. Now, it is actually waiting for me to type something. So I can type whatever I want to type, and all that content will get into the file. Okay? So I'll just use a pound sign. The pound sign is the beginning of comment in your source file. So we'll just say this is a program that I copy from the web page. Okay, just so that you can see that I can type something here, and then I can copy and paste later. So now it's time for me to paste, and to paste inside Linux is the middle button of your mouse. Okay, I just pasted the selection that I have copied from the browser. Is that okay so far? All I did was to press the middle button when I'm in Linux. If you're using Windows and using PuTTY, you have to right-click. Right-click will accomplish exactly the same thing, which is pasting whatever is in the clipboard. Is that okay so far? So I can type some more stuff here. Okay, this is the end of the program. Oh, but how do I get out now? Control C is one way to get out, but Control C really means it's a very rude way to get out of a program. Okay, you're basically telling the program "butt out." Okay, so it's much better to ask the program more politely, which is Control D. Okay, Control D in Linux means end of file. Okay, so when I press Control D, I'm just telling the program this is all that I want to input. And the program terminates, normally in this case. So the next thing we want to do is to go back into the text file just to make sure that it does have all the content, starting with this is a program that I copied from the web page, and ending with this is the end of the program, because I want to make sure I'm not just including the part that I paste, but also including the stuff that I type manually. There are several ways to do it. I can use less if I want to. I can use cat if I want to. So cat, and then followed by the file name, would type the content. Because in this case, when I use cat, I only specify the input file, but I do not specify the output file. When you don't specify the output file, it defaults to standard out, which is basically the screen by default. Okay. Are there any questions at this point? I just verified, the content of the file. Is that okay so far? Okay. So the next step is to assemble the program. Now, why do we have to assemble the program? We'll talk about compiling later, so I'll kind of defer that discussion, to a later time. To assemble this program, you only need to invoke, AS, which stands for assembler. With the file name of the assembly source code file, the following command should do it. Now this command already specifies quite a few things. --g steps is basically telling the assembler to generate the debugger symbol tables. Okay, we'll talk about that when we get to GDB. Okay, -o specifies the name of the output file. If you don't specify -o, it will default to a.out as the output file name. And then we have test.s, which is the input to the assembler. And all of this stuff is explained down here. And once again, if you want to, If you don't want to type all this command here, you can just copy, switch over to the command line, and paste just like that. Okay? But remember, you cannot do this in the virtual machine console itself. You can only do this in PuTTY. So that means if you want to do a copy and paste, you have to start up the machine, with a console, but don't do anything with the console. Just leave it alone. And then you have to use PuTTY to connect to the virtual machine. Then you can do all the copy and paste. Is that clear? I mean, do you guys understand what I'm saying? Yes? Okay. Now, I want to double check to make sure that this does create an output file, which is called test.o, which stands for, this O does not stand for output, it stands for object. Okay, so we want to make sure that we have an object file in this case. So we can do it. ls all by itself will display all the file, or it will display all the content within the current folder. I can also be a little bit more specific. In other words, I can say ls test.o, which will only display the file test.o. But I can also display more detail using the -l option. -l, this is a lowercase l, will display all the details of this file. It tells me that it is created by a user called user. It is 800 bytes long. This is the time and the date of the creation of this file. So that can come in handy if you want to see, okay, when did I create this file? Is this file up to date? You can use ls-l to help you, determine when the file was created, when it was last updated. Any questions at this point? You can also do ls and -l without any file name. Then it will just apply the same option to all the files and subfolders of this current directory. Okay. Questions? Okay. So we switch back to the instructions. We are ready to move on to the next step. The next step is linking. Strictly speaking, the assembler outputs a binary code that can be understood by the processor. In other words, the assembler is already a translator. It translates from the text representation of the program to a binary representation that contains the opcode, or it contains the binary code that the processor can understand. But it's not done yet, okay? And that's because the file format of the output of the assembler is not suitable for the operating system to load the program and actually start execution. To do that, we need to rely on the linker. The linker here is called LD. The name of the linker is LD. It is used to resolve references of labels and output a single file that is an executable, and the command is like this. We'll talk about this later, why it seems to be somewhat redundant. Okay, we have AS to assemble the file, to translate the assembly language program into binary code. How come we have one additional step called a linker to create the actual executable? I cannot explain it right now because I only have one source file for this particular program. When we get to the point where we have multiple source files for the same program, then it starts to make sense to have a linker. Okay? And how many people have exposure to that concept of linking already? Okay? Not the entire class, but with several people. We'll talk about that when we get to the right part of the class. And in this case, -o test.out specifies the name of the output of the linker. Because if you don't specify that, once again, the default is just a.out. So we'll go ahead and run the command, ld-o test.out and test.o, this time as the input. No problem. And we'll take a look using ls. You can see that test.out